Hi everybody, in this video we're learning how to solve simultaneous equations using a method called substitution. This is a pair of simultaneous equations. My job is to find a value of x and a value of y such that both this equation and this equation are true. So how do I do that? Firstly, I look at the equations and I see that the first equation tells me that 3x plus 4y is equal to 2. This means 3 lots of one number plus 4 lots of a second number gives me the number 2. The second equation, this one here, tells me that x is equal to 7 plus 5 lots of y. Now what I'm going to do here is if x is equal to 7 lots of 5y, then this x is the same as this x, then I can pop this here, 7 plus 5y, into that value of x. I can substitute 7 plus 5y into the x in that first equation. Look at how I do it. Well, the first equation says 3x plus 4y is equal to 2. Instead of this x here, I'm going to write this value here, 7 plus 5y. So I'm going to go 3 lots of, and I use brackets, 7 plus 5y, then continue, plus 4y is equal to 2. The next thing I need to do is expand out these brackets. 3 lots of 7 plus 3 lots of 5y plus 4y equals 2. Next I can collect like terms. 15y plus 4y will make 19y, and I've still got my 21 here. 21 plus 19y is equal to 2. Next I need to solve this equation. Well, I've got 21 here. I can take 21 off both sides. That leaves me with 19y is equal to 2 minus 21. That's negative 19. How do I solve this now? Divide by 19, and y is equal to negative 1. Now, this is my first solution, y equals negative 1. But I want to know what x is and what y is. Well, what is x? I know that x is equal to 7 plus 5y. I'm going to substitute y equals negative 1 into this equation. X is equal to 7 plus 5 lots of negative 1. X is equal to 7. 5 lots of negative 1 is negative 5. X is equal to 2. My solution to this pair of simultaneous equations is x equals 2, y equals negative 1. And I can check my work. What I'm going to do now is substitute 2 and negative 1 back into the equations. So what are the equations? 3x plus 4y equals 2. Let's try. Let's see if I've got something true. I'm going to put 2 in there and negative 1 in there. 3 times 2 is 6. 4 lots of negative 1. 4 lots of negative 1, that's negative 4. 6 plus negative 4 is the same as 6 minus 4. That will give me 2, which is what it's meant to equal. So my solutions for this, x equals 2, y equals negative 1. Here is another set of simultaneous equations. We have x equals negative 10 plus 4y, and 3x plus 5y is equal to 21. Well, how am I going to do that? I know that x is equal to negative 10 plus 4y. Here is an x here. Instead of that x, I'm going to put in negative 10 plus 4y. Watch how I do it. 3 lots of x, which is negative 10 plus 4y. Then I continue on with the equation with this part here. Plus 5y is equal to 21. Next, I'm going to expand out the brackets. Negative 30 plus 12y plus 5y equals 21. Simplify my expression, collect these like terms, 12y and 5y. 17y. What can I do next? How do I get rid of minus 30? I'm going to add 30 to both sides. Negative 30 plus 30, nothing, just leaving me with 17y there. 21 plus 30 is 51. Divide by 17. Y is equal to, use my calculator, and I think that is 3. So I've now got a y value. Have I finished the job? No, not yet, because I've still got to find what x is. I can use either that equation or that equation, doesn't matter which. I'm going to use the top one because it looks easier. Okay, y is equal to 3, so x is equal to negative 10 plus 4 times 3. Negative 10 plus 12, that gives me x equals 2. So our solution here to this pair of simultaneous equations is x equals 2, y equals 3. Now I'm just going to check. How do I check it? I'm going to choose one of the equations. I might choose this second one here. 3x plus 5y equals 21. Let's see if that's true. X is 2, so 3 lots of 2 will be 6. Y is 3, so 5 lots of 3 is 15. 6 plus 15 does indeed equal 21, so I know that I'm correct. Here's another pair of simultaneous equations. Think about what substitution you would do. First thing I notice I have here for x, 9 minus 4y. X is equal to 9 minus 4y, and here's an x here. I could substitute this 9 minus 4y into that equation for x. That's what I'm going to do. So I'm going to go 3 lots of 9 minus 4y, not forgetting my brackets there, plus 2y is equal to 12. What do I do next? I expand my brackets. 27 minus 12y plus 2y equals 12. Collect like terms, there's a bit of a trap here. Remember, this is minus 12y plus 2y. Minus 12 plus 2y will give me minus 10y. I've still got this 27 over here. It's equal to 12. What am I going to do next? I want to get rid of this 27. That's a positive 27. So take 27 off both sides. That leaves me with this one here. Don't forget the negative. Negative 10y equals 12 minus 27. Use your calculator for these if you're not fast with your number facts. That will give me a negative 15. Divide by negative 10. Divide by negative 10. And y is going to be 1.5. Sometimes we get whole numbers and sometimes we don't. It doesn't need to bother us. Now, remembering that I have found y here, but I haven't finished the problem because I've also got to find x. So I'm going to write down one of my equations again. Use this one here. X is equal to 9 minus 4y. So x is going to equal 9 minus 4 lots of 1.5. Just pop that in my calculator. And I get x is equal to 3. So our solutions here, x equals 3, y equals 1.5. That's our solution. Now what I need to do next, of course, is to just check that. I'm going to find one of my equations. I might use this first one. 3x plus 2y equals 12. Let's see if that's right. 3 times, well, x is 3. 3 lots of 3 plus 2 lots of 1.5. That's 9 plus 2 lots of 1.5 is 3. And 9 plus 3 does equal 12. So I know that I'm correct. Here's another example. Why don't you press pause on the video and see if you can find a solution. Okay, well, what do we notice here? We've got y is equal to 41 minus 5x. And here we've got y here. So I'm going to pop that into that. I'm going to substitute 41 minus 5x into the equation. 3x plus 2 lots of, well, y, which is 41 minus 5x, is equal to 33. What do I do next? Expand out. That's going to be 82, 5 2s are 10, minus 10x equals 33. Next thing I need to do here is collect like terms, and I need to make sure I don't muck up my negatives. 3x minus 10x, that's going to give me negative 7x, and then I have plus 82 equals 33. What do I do next? Well, I'm going to subtract 82 from both sides. That gives me negative 49 over here. And here we have negative 7x. Negative 7x equals negative 49. Divide by negative 7. Cancel. X is equal to 7. But have I finished the question yet? No, I haven't. I've still got to find out what y is. Well, I know that y is 41 minus 5x. So y is equal to 41 minus 5 lots of 7. 41 minus 5 sevens are 35. So y there is going to equal 6. How did you go with that one? Of course, we should give it a quick check. I'm going to check with 3x plus 2y equals 33. That's our first equation. And I'll substitute my x value in here. 3 lots of 7 is 21. Substitute my y value in there. 2 lots of 6 is 12. 21 plus 12 does equal 33. So I know that I'm correct with that. Here's another one for you to have a go at. Press pause on the video. Okay, how are we going to go about this? Well, we have y here, and I know that y is equal to 11 minus 5x, and here's y here. So I'm going to substitute that into there. So what I've got is 4x plus y is equal to 9, which means 4x plus 11 minus 5x. Notice there's just one y here. I don't need to put any number out there. It's equal to 9. Now, I don't have to expand the brackets here. I can just get rid of the brackets because there's nothing out the front. Collect like terms. 4x minus 5x, that will give me negative x, negative 1x. Plus 11 equals 9. Subtract 11 from both sides. We have negative x equals 9 minus 11 is negative 2. Now, I'm not interested in what negative x is. I want to know what positive x is. So remember, this is negative 1x here. So what I'm just going to do is divide both sides by negative 1. I can cancel out those negative 1s, and I have x is equal to 2, positive 2. Have I finished yet? No, I haven't. I need a y equals as well. I'm going to use this equation. Y equals 11 minus 5x. Y equals 11 minus, well, here's x equals 2. 5 lots of 2. 5 lots of 2 is 10. 11 minus 10 is 1. So our solution here, x equals 2, y equals 1. Let's check it. I'm going to use first equation here. 4x plus y is equal to 9. That's 4 lots of 2 is 8 plus y, which is just 1, and that does indeed equal 9, so I know that I'm correct. I've got a slightly different type of equation to show you now. You'll notice here I've got y is equal to this, and y is equal to that. Well, if y is equal to this and y is equal to that, then this must be equal to that. Let me show you what I'll do. I'm going to go 2x minus 11 is equal to this bit here, 4x plus 1. Now, this is an equation that we can solve. This is an equation with variables on both sides. What I need to do, I need to get this 4x and get rid of it. How do I get rid of a 4x? Well, I'm going to take 4x from both sides. What do I have left here? I've got 2x minus 4x. That will give me negative 2x. I've still got minus 11 is equal to 1. What am I going to do next? Add 11 to both sides. That will give me negative 2x is equal to 12. Divide by negative 2, divide by negative 2. X is equal to negative 6. Have I finished the problem yet? No. I just need to find out what y is equal to. Well, y is equal to, I can use either equation. I'm just going to use the first one. Y is equal to 2x minus 11. Y is going to equal 2 lots of, what's x? 2 lots of negative 6 minus 11. That is going to equal negative 12 minus 11. And my calculator will tell me what that is. Negative 23. Here's one for you to try. Notice that what we've got is y is equal to this and y is equal to that. If y is equal to this and y is equal to that, then this must be equal to that. Press pause and solve the problem. Okay, so we've got 5x minus 8 is equal to negative 3x plus 16. What am I going to do next? I need to get rid of this negative 3x. I'm going to add 3x to both sides. Over here we've got 5x plus 3x will give me 8x. I've still got minus 8 equals 16. Add 8 to both sides. And I have 8x is equal to 24. Divide by 8. X is equal to 3. Have I finished the problem? No, I haven't. So I just choose one of the equations. I'm going to use this one this time. It doesn't matter which one I use. Y is going to equal negative 3 times x, and x is 3, plus 16. That's y equals negative 9 plus 16, but you can just put that in your calculator. And that will give us y is equal to 7. Okay, I'm now going to use this one as my checking one. Got y is equal to 5x minus 8. Let's see, y is 7 equal 5 lots of x is 3. 5 times 3 minus 8. Put that in my calculator and yes, 7 is equal to 7, so I'm right. My solution is x equals 3, y equals 7. Here are two for you to try by yourself now. Notice that for this one, we've got x is equal to this and 2x plus y is equal to negative 4. So for that one, you can do a substitute in there, not forgetting to use your brackets. For this second one over here, we've got y is equal to this and y is equal to that. So you're going to have this is equal to that. Press pause on the video and give them both a try. Okay, let's look at the first one. We've got x is equal to this. So I'm going to substitute 7 plus 4y in instead of x, remembering to use my brackets. Plus y is equal to negative 4. Expand. 14 plus 8y plus another y equals negative 4. Collect like terms here. 14 plus 9y equals negative 4. Take 14 off both sides. 9y is equal to minus 18. Divide by 9. Y is equal to negative 2. Next I need to find what x is. X is 7 plus 4y. X is going to be 7 plus 4 lots of negative 2. 7 plus negative 8. That's going to be x is equal to negative 1. So our solution here, x equals negative 1, y equals negative 2. How did you go with that? For this other one here, we've got y is equal to this and y is equal to that. So this 3x plus 8 is equal to x plus 2. Okay, what am I going to do to solve this now? I've got this x here. Let's take x off both sides. Now remember that's 1x, 3x, take away x. 3x minus 1x is going to leave me with 2x plus 8, they go away, is equal to 2. Take 8 off both sides, and I've got 2x equals 2 minus 8. 2 minus 8, that will be negative 6. Divide by 2, divide by 2. X is going to be negative 3 there. Have I finished? Not at all. Y equals x plus 2. Y is equal to negative 3 plus 2. Y is equal to negative 1. So our solution for that one, x equals negative 3 and y equals negative 1. And two last ones to finish with. This one over here, what have we got? We've got y is equal to that, and we've got a y here. Have a think about what you'd like to do with that one. Press pause. Okay, I'm going to substitute x minus 6 into here for y. So I've got x plus 2 lots of, remembering to use brackets, x minus 6 is equal to 3. Expand out the brackets. Collect like terms, x plus 2x. 3x minus 12 equals 3. Add 12 to both sides. 3 plus 12 is 15. Divide by 3. X is equal to 5. And we still need to find out what y is. Y is equal to x minus 6. X is 5, so y is equal to 5 minus 6, which is equal to negative 1. So our solution for this one, x equals 5, y equals negative 1. Next, over here, we've got y is equal to this, and y is equal to that. So this must be equal to that. 2x plus 6 is equal to negative x plus 12. Okay, I need to get rid of these x's. How do I get rid of a minus x? I plus x. Add x to both sides. Well, over here I've got 2x plus another x is going to be 3x plus 6 equals, well, there you go, 12. Take 6. 3x is equal to 6. Divide by 3, divide by 3. X is equal to 2. Haven't finished yet though. I need to find y. Y is equal to 2x plus 6. If x is equal to 2, 2 times 2 is 4 plus 6. Y is equal to 10. So my solution for that one, x equals 2, y equals 10. Okay, hopefully you're starting to get the hang of doing these. Simultaneous equations are a big part of Year 10 and Year 11 maths.